Hello and welcome to Chapter 5. We're going to start with a look at exponents and then take a look at some polynomials, adding and multiplying them. So start off some rules with exponents. Again, we've seen exponents before. If I have 2 to the third, that just means 2 times itself 3 times. And we get 8. Okay, if we have a negative number, say negative 2, right, raised to the third power, this is negative 2 times itself 3 times. We get negative 8. If I say, though, negative 2 to the fourth power, right, when I do not have parentheses around the negative 2, right, that means I have that negative sign out front, and what's being multiplied 4 times is just 2 times itself 4 times. So in this case, right, we have a negative 16. Whereas if we did negative 2 in parentheses to the fourth power, right, this is negative 2 times itself 4 times, and we get a positive 16. And the key thing here is to be looking for negative signs, right, whether that negative number is in parentheses, in that case it's the negative number being multiplied by itself. And if it's not, it's just your result will be negative. Some other basic ideas of exponents. Right, let's take a look. Right, when I had 2 cubed here, I had 8. When I got 2 squared, this is 4. 2 to the first then is 2. And 2 to the 0 power. Right, in this case, if we follow that trend, it should be 1. And we'll see anything, right, to the 0 power is 1. So 3 to the 0 power also equal to 1. Another rule for exponents is called the product rule. If I had, say, x squared times x cubed, what this is saying is x times x for my x squared, and that's being multiplied by x cubed, which is x times x times x. So what I really have here is x times itself 5 times, or x to the fifth. So when we're multiplying things with exponents, we will always want to add our powers. So for example, y squared times y to the fifth, and this is going to be y to the 7th power. Or if we had, say, b squared times b to the third, okay? Again, we add our powers, 2 plus a power of 1, right, which we just don't write here, times a power of 3. So we have b now to the 6th power, right? 2 plus 1 plus 3 gives us 6. So we're always adding the powers to get our new power. So if I have, say, x cubed times 2x plus 3x squared, right? I distribute here x cubed times 2x with my 2 and then x to the 4th, again adding those powers. And then this plus, right, my 3, then x cubed times x squared, I get x to the 5th. Again, just adding powers. Now here, again, I cannot add these together because they are not like terms. You can also raise a power to a power. That's when I take, say, x squared and I raise that to the 3rd power. Right, what this is saying is I have x squared times itself, right, 3 times. So we have x squared times x squared times x squared. This, right, if we add those powers, we get x to the 6th. Basically what we end up doing is multiplying when we have a power to a power. So for example, y to the 5th to the 3rd is going to be y to the 15th. We can also do a product to a power. That's when I have, say, 2x raised to the 3rd power. Okay? Everything inside here is going to be raised to that 3rd power. So 2 cubed, 8, and x cubed, just x cubed. Okay? I can also have, say, 3xy squared, and I raise that to the 5th power, I have 3 to the 5th, which is 243, x to the 5th, which is x to the 5th, and y squared to the 5th, y to the 10th. So again, each piece in here is getting raised to that 5th power. I can also have a quotient to a power. That's when I have x over y raised to the 3rd power. Okay, each piece in here is also going to be raised to the 3rd power. X cubed over y cubed. Or if I had, say, a squared over 2x to the 3rd, and I raise that to the 4th power, I get a to the 8th over 16x to the 12th. So those are our power rules. We'll be using them more as we get to multiplying polynomials in just a little bit. Next, we're going to take a look at adding and subtracting polynomials. Polynomials come in a few different groups. We start with monomials. Monomial is a term. It's basically anything that has a coefficient, a variable, to a power. So 2x squared, this is a monomial. When I add two monomials together, I get a binomial. So if I have 2x squared and I add that to, say, 3x, this is now a binomial because it's two monomials being added together. There's two of them, hence bi. So binomial. And lastly, we have trinomials. That's when you take three monomials and add them together. So you can have 2x squared plus 3x minus 7. This is a trinomial because it has three terms, 2x squared plus 3x minus 7. All of these are considered polynomials, poly meaning many. The other thing to know about these is you can also identify coefficients as well as degrees of terms and degrees of binomials, trinomials, or polynomials. A coefficient is always just the number in front of the term, so my coefficient for this monomial is 2. My coefficient for this monomial is 2, or the coefficient for this one is 3. Coefficient here again 2, 3, and this time my coefficient is a negative 7, including that sign. Degree of a polynomial is the highest power in that polynomial. For example, here this monomial has a degree of 2. This, right, the highest power here of the variable, we have a power of 2 and a power of 1, so degree of 2. And then again here our highest power is 2, degree of 1, and degree of 0 for each of those terms. So the degree of this trinomial is 2. One clarification for degrees: if you have 3xy squared, to find the degree of this term, you add the powers of each variable, and that is the degree of the term. So this has a degree of 3. When it comes to adding polynomials, we just need to remember how to add like terms. So for example, 5x squared minus x squared. These two are like terms because they have the same variables to the same powers. So they both have an x squared, which makes them like terms. In that case, we just add or subtract the coefficients of each in order to combine them. So here we have 5x squared minus x squared gives us 4x squared. Basically, it's like saying I have 5 of these things, 5 apples, minus an apple, and I have 4 apples left. So whatever made it a like term has to stay there in your answer. You can also have more than one variable, say 7a squared times b plus 10ba squared. Again, these are like terms. They may not look like it right away, but they are. They have the same variables raised to the same powers. I have an a squared and a b, an a squared and a b in both situations. So I just, again, add the coefficients, 17, and then my variables, I can put them in whatever order I want, either ba squared or a squared b. I'll usually put them in alphabetical order, so a squared b for my final answer. If they do not have the same variables to the same powers, they are not like terms and you cannot add them together. For example, 3x squared plus x They have the same variable, but not to the same power, so you cannot add them together. And this is as simplified as it gets. Also, 3x squared plus y squared, they have the same powers, but they aren't the same variables, so again, they are not like terms, and you cannot add them together. Only when you have the same variable to the same power. You can also add some longer polynomials together. Say I have this binomial 3x plus 4, and I want to add to another binomial minus 4x plus 2. At this point, I check to see if anything is being done to these parentheses or inside these parentheses, and there is not. Right? So I don't need them. Right? I can just rewrite this as 3x plus 4, right, plus a negative 4x. I'll keep that in parentheses, plus 2. Only reason I put that in parentheses is so that I don't have a plus sign and a minus sign right next to each other. Of course, I could have rewritten this just to be minus 4x, but it's equivalent this way. So when I go to add these, I add my like terms, 3x and a negative 4x, which gives me a negative x, and then 4 plus 2, which gives me plus 6. And that is my answer for adding these two polynomials. What if I subtract polynomials? Say I have y squared minus 2y plus 1. I'm going to subtract from it 3y squared plus y plus 11. Now here again I check to see if anything is happening inside or to these parentheses, and in this case there is. I have a negative sign in front of this parenthesis, which means I need to distribute this negative sign. Over here, nothing is happening to it, so I can just rewrite those. Y squared minus 2y plus 1. And then I distribute this negative sign, minus 3y squared minus y minus 11. Then I can combine my like terms. I have y squareds in common, which gives me a negative 2y squared. I have like terms with just a y, giving me negative 3y. And I have like terms that are just numbers, 1 and negative 11. When I add those together, I get negative 10. All of these now do not have like terms, so I cannot combine any further, and this is my final answer. That'll about do it for adding and subtracting polynomials. It really is just combining like terms and making sure to distribute negative signs when you see them. Now we get to more of the interesting bit, multiplying monomials and polynomials. Let's start with some monomials. If I have negative 5x to the 4th, and I multiply that by 4x cubed. When I'm multiplying monomials, I need to just multiply the parts that are alike. So for example, my numbers here, negative 5 times 4 gives me negative 20, and then x to the 4th times x cubed. We remember our power rules, so we add those exponents and get x to the 7th. So multiplying these two monomials, I get negative 20x to the 7th. The reason I can multiply just the parts is because basically all of this is one long multiplication problem. Negative 5 times x to the 4th times 4 times x cubed. And we learned from our properties of real numbers about the commutative property. I can multiply things basically in any order. So I can multiply these two together, and I can multiply these two together. And since I do not know what x is, I'm always going to just leave it in its variable form. Right? So I have my negative 20 times that x to the 7th. And this is why I can multiply this way. I can make those monomials a little bigger. Say I have 7xy squared, and I multiply that by x cubed y squared. Again, here I multiply the parts that are alike. Since there's no coefficient here, I can always assume a coefficient of 1. So 7 times 1 gives me 7. X times x cubed, I get x to the 4th, again because I'm assuming a power of 1. And then y squared times y squared, I add those powers together and get y to the 4th. That's about as interesting as it gets with monomials. So let's go ahead and move up to some binomials. We'll start with a monomial times a binomial. For example, 5x is a monomial times a binomial 3x squared plus 4. In this case, again, I'm distributing. I'm multiplying this one piece by each piece inside the parentheses. So 5x times 3x squared, I get 15x cubed. And then plus here 5 times 4, 20. And then that x, since there's no variable here, x times nothing here is just x. So if I have a term with x times just a number, right, that x just comes down. So here I have my final answer, 15x cubed plus 20x. Let's take negative 4x cubed and multiply that by 3y squared minus 2y plus 3x. So here again I just distribute. I have negative 4 times 3, which gives me a negative 12. X cubed, well, there's no x term here, so I just have x cubed that comes down. And I have here this y squared, which also comes down. Next, negative 4 times negative 2 gives me a positive 8. There's no x term here, so I just bring down my x cubed, and then bring down my y. Next, I have negative 4 times 3 gives me a negative 12. And now I have similar variables, x cubed times x gives me x to the 4th. And this then is my simplified polynomial. The real interesting part is when I get to binomials times binomials. So let's take a look at that. If I have x plus 4 times x minus 2. Okay, when I have a binomial times a binomial, I'm doing something similar to what we did before, except now I take each piece here and multiply it by everything. So this term x gets multiplied by each piece in the parentheses, and this 4 gets multiplied by each piece inside the parentheses. So I have x times x, which gives me x squared, x times negative 2, which gives me a negative 2x. Then I have 4 times x, which gives me 4x, and 4 times negative 2, which gives me a negative 8. Now when I do this, I have to check my answer to see if there are any like terms. In this case, there are. So I have x squared plus 2x minus 8. And this now is the product of those two binomials. Let's try another example. This time let's take 3x plus 2 times x minus 7. Again, here I take each term and multiply it by the others. So I have 3x times x, which gives me 3x squared. 3x times negative 7, which gives me a negative 21x. Then I go to my 2 times x gives me a positive 2x, and 2 times negative 7 gives me a negative 14. I then combine my like terms, so I have 3x squared minus 19x minus 14. And that now is the product of those two binomials. I can carry this idea on to a binomial times a trinomial. Let's take 2x plus 3 and multiply that by x squared plus x minus 1. Again, I do the same thing. I take this first term and multiply it by each term in the parentheses. So I have 2x cubed. Then 2x times x, I get plus 2x squared. And then 2x times negative 1, so I get negative 2x. Then I move on to my 3. 3 times x squared gives me a positive 3x squared. 3 times x gives me a positive 3x. And 3 times negative 1 gives me negative 3. Now I combine all of my like terms. Let's first identify them. We have 2x squared terms here and here. And we have 2x terms here and here. So we'll go ahead and combine those. Let's first start with our highest degree term here, 2x cubed Then we'll combine our x squared terms, so plus 5x squared, and then our x terms, so plus x, and then our number minus 3. When we write our terms in that order, starting with the highest degree first and working our way down, that is called writing it in descending order. That is the standard way to write terms when they each have a different degree, starting from highest down to lowest. So this then is our answer. This is the product of that binomial times a trinomial. Let's try another. This time let's take x to the fourth plus 2x cubed minus 5. And we're going to multiply that by x squared plus 1. Okay, it does not matter the order. I can still take each term here and multiply it by each term in the second parentheses. So we take x to the fourth times x squared, which gives me x to the sixth, x to the fourth times 1, so plus x to the fourth, then 2x cubed times x squared, which gives me plus 2x to the fifth, because I'm adding those powers, and 2x cubed times 1 plus 2x cubed. Then my negative 5 times x squared minus 5x squared, and minus 5 times 1, negative 5. We need to identify our like terms. There are no like terms here. Okay, so we can leave it like this, or we can choose to rewrite it in descending order as x to the sixth plus 2x to the fifth plus x to the fourth plus 2x cubed minus 5x squared minus 5. And that is now our polynomial in descending order. We can use this idea to multiply two polynomials of any size that we want. Again, just taking each term in the first polynomial and multiplying it by each term in the second polynomial. That's all there is to multiplying polynomials together. That will do it for the first 3 sections of Chapter 5. Be sure to take notes on this and complete the homework and quiz over the first 3 sections. If you have any questions, you can always email me. I will see you for the rest of Chapter 5 next week.